Welcome to another Embedded Talk series brought to you by Inventek Systems. Today's Embedded Talk will cover the eS-WiFi Soft Access Point mode. The eS-WiFi modules are wireless LAN modules that are typically embedded into devices and appliances that connect to home networks, Wi-Fi hotspots, and workspace networks. The eS-WiFi family of 802.11 BGNN modules have an embedded microcontroller running a fully integrated TCP/IP stack and a simple-to-use AT command set. The eS-WiFi modules are based on Broadcom's Wi-Fi technology. Now on to the discussion about the eS-WiFi Soft Access Point mode. The Inventek system eS-WiFi modules are offered with a complete TCP/IP stack and require only a simple AT command over the USB UART SPI interface to communicate with the module. In a typical embedded application, a simple 8-bit, 16-bit, or 32-bit microcontroller can be used to send the AT command to initiate a soft access point. Once the access point is started, other devices or users can join the network and be connected as a client on that network. What follows is a discussion on example use cases of the eS-WiFi soft access point. Use case number 1, soft access point configuration. In use case number 1, software access point configuration, you have an eS-WiFi module that is in a thermostat. The eS-WiFi module is running a software access point that will be accessed by an iPad, a PC, or a smartphone as a web browser to configure the thermostat as a client onto a network. When the thermostat that has the eS-WiFi module embedded in it is powered on for the first time, the eS-WiFi module will come up with a software access point loaded and running. The user can then use a Wi-Fi enabled device that has a browser capability to access the software access point that is running on the eS-WiFi module that is embedded inside the thermostat. The eS-WiFi software access point will present back to the Wi-Fi enabled device browser page a configuration page listing the available access points that it has detected in its area. The list will contain network name, signal strength, security, and Wi-Fi channel being used by access points in the area. The user can then decide which access point they would like to have the thermostat associated with and choose join that is beside that access point name. Once the join is selected, the eS-WiFi module that is running inside the thermostat will then close down the access point and exit back to its AT command set console, waiting for future commands. At that point, the thermostat is now joined to the network and can exchange information with applications and web pages running on Wi-Fi enabled devices on that network. Use case number 1 shows how easy it is for a product that has an eS-WiFi module embedded in it to join a Wi-Fi network in order to exchange information with devices on that network. Use case number 2, direct connection. In use case number 2, direct connection, the eS-WiFi is embedded in a device such as a printer and is in the soft access point mode. Users can then locate the eS-WiFi soft access point, join the eS-WiFi's network, and then pass data to the printer from their device. This can be used with any device such as a smartphone, laptop, or tablet. The user would like to pass information to the eS-WiFi, or in this case to the printer via the eS-WiFi over the soft access point. The soft access point will generate the DHCP request for the computers connected. Up to 8 users can be connected to the eS-WiFi access point in this mode. Use case number 2, direct connection, shows how easy it is to use the eS-WiFi to allow wireless devices to connect to each other to exchange information. To demonstrate the soft access point capabilities of the eS-WiFi module, we'll be using TerraTerm, Firefox, System Sim, and Windows Command Console. First thing we want to do is to power up the eS-WiFi board. Once the eS-WiFi is up and running, we want to put the eS-WiFi console into human readable command mode so we can see the commands that we enter at the console. We do this by entering $3 on the console. Next we enter A0 to put the eS-WiFi module into soft access point mode. Once the eS-WiFi access point is started, we then go to our host computer and we select the eS-WiFi's access point. Then we enter 192.168.1.1 in our browser for the eS-WiFi access point. Once the eS-WiFi browser page is loaded, we're presented with a list of access points in an area that we can have the eS-WiFi module to log on to. To select the access point for the eS-WiFi to log on to, we select the join beside the access point of interest and then enter the password for that access point. The eS-WiFi module will then join the selected access point network and shut down its own access point. Looking at term, we can see that the eS-WiFi module has shut down its access point and has received a DHCP address from the access point that it joined. The next example will demonstrate device control between wireless devices. This example will be using term, system-sim, DOS console command box. We'll use the IP command to get our IP address for the host platform, in this case the host PC, and the notepad will show here the steps necessary to do a TCP communication between the devices. The first step is to power up the eS-WiFi and make sure it's operational. The first thing we're going to do is enter the command mode, followed by entering C1 equal to our access point, in this case access point, C2 equal to the password for the access point, in this case the password is password with a capital P and a capital W, and then we will enter C3 equal our security protocol. Then we'll enter C4 equal 1 for DHCP mode, followed by C0 to join the access point. Next we want to start the system-sim TCP server. System-sim will open up a TCP port at 8001. System-sim is a simple TCP server application written for the Windows PC environment. With System-sim, you can set LEDs to be on or off, you can set the value to be displayed on 7-segment displays, and read toggle switches, all via a client attached to System-sim over a wireless network using TCP communications. Next, I'm going to use ipconfig in the Windows DOS box to read the IP address of the Windows host PC. We can see from ipconfig that the Windows host PC address is 192.168.10.100. Next, we want to set up the environment for TCP communications on the eS-WiFi module. We set S1 equal 4 to represent the number of bytes to send in a TCP packet. Then we set S2 equal 5000 for a 5-second delay on the TCP transmit. The 5-second delay represents the amount of time to wait before sending the 4 bytes. This could be if you had 2 bytes, it would wait 5 seconds and then send those 2 bytes, or when you reach the maximum buffer size you would define with S1, in this case 4 bytes, it would send the 4 bytes immediately when the 4 bytes had been reached. In the TCP console buffer, we set R1 equal 20 to represent the number of bytes to read in a single TCP read from the TCP communication buffer of the eS-WiFi module. Next we set R2 equal 5000 for a 5-second delay for reading from the TCP buffer. So if no data is available in our read, we'll wait 5 seconds and return. If data is available, return the available data up to the size of the buffer value that was set with R1. Next we set P1 equals 0 to select TCP communications. Then we set P3 equal to 192.168.10.100, which was the IP address of the Windows host PC that we found in the IP command from the Windows DOS box. Next we set P4 equal to 8001. 8001 is the TCP port being used by the SIM system software on the Windows PC host. When we're ready, we set P6 equal 1, which will actually cause the eS-WiFi module to connect to the SIM system software on the PC host via TCP port 8001 as a client. Following the P6 equals 1, we can see on the system SIM software that it has received a connection from a client, and we can see on the eS-WiFi module that is connected to 192.168.10.100, which is the address we found through the IP config in the DOS box for the Windows host PC where the System SIM software is running. We are now ready to send messages to System SIM to control the LEDs and to read the switches via TCP over port 8008. The SIM system software uses simple messages to control the LEDs, the 7-segment display, and read the switches. It is as simple as S0 enter, LA enter for the LEDs on the System SIM software to be turned on. After entering LA enter, we can see on the System SIM software that the LEDs have turned on. We can also see on the System SIM software that it sent a message, LEDs on, to the client. We can then use the R0 command to read the message on the eS-WiFi module. We can see when we use the R0 that LEDs on was the message received, which was the message that was sent to us by the SIM system software running on the Windows PC host. Next, on the System SIM software, we can toggle a few of the switches and read those switches via the eS-WiFi as a client to the System SIM software using the command TA, which will read the toggle switches. However, in this case, I'm going to enter an invalid command of RA, which will be sent to the System SIM software. It will be recognized as an invalid command by the System SIM software and will be returned to us as invalid command. And then we'll enter TA to read the switches. And then we'll follow that with an R0 to read the return value. And what we'll notice is that we will get the last value sent, in this case the invalid command from the System SIM software. And if we do an R0 again, we'll get the next command, which was the switch values, in this case switch value 5, which looking on the System SIM software we can see it sent a switch value of 5. Next, we'll do a P6 to shut down the TCP communications, and we'll notice in the System SIM software that the TCP communications were closed by the client. That is how easy it is to control a device via TCP with the eS-WiFi module as either a client or a server. The eS-WiFi module also has the ability to be a server for TCP communications as well as a client. Thank you for your time in watching this video. For further information, please contact Inventek Systems.